Hello students, I am Hitesh Manglani and today we will discuss about some special functions. So let's start. So first of all we will discuss about Bessel's function. So the Bessel function of order n is denoted by Jnx, okay, where n is a positive real number or 0. Okay, and it is given by Jnx is equal to sigma m equal to 0 to infinite minus 1 raised to m whole divided by m factorial into gamma of n plus m plus 1 into x divided by 2 whole raised to n plus 2m. So this is how Bessel's function of order n is defined. Now we will discuss properties of Bessel's function. So main properties of Bessel's function are j minus n x is equal to minus 1 raised to n into jn x if n is a positive integer. Second property is jn plus 1x is equal to 2n divided by x into jn x minus jn minus 1x. And third property is derivative of x raised to n into jn x is equal to x raised to n into jn minus 1x. So these are main properties of Bessel's function. Now we will discuss about Dirac's delta function. So Dirac's delta function is defined as delta t minus a, that is equal to limit epsilon tends to 0 f of t, where f of t is equal to 0 for t less than a, and it is 1 upon epsilon for a less or equal to t less or equal to a plus epsilon, and it is 0 for t greater than a plus epsilon. Now here we can see the graph of this. So here from the graph we can say that value of function is 1 upon epsilon for a less than equal to t less than equal to a plus epsilon, okay, and for t less than a it is 0, and for t greater than a plus epsilon it is 0. So this is how Dirac's delta function is defined. Now we will discuss error function and complementary error function. So the error function of x is denoted by ERF of x, where x may be real or complex variable, and it is defined as ERF of x, that is equal to 2 divided by square root of pi integration 0 to x into e raised to minus t square dt. Okay, now we will discuss the complementary error function. So the complementary error function is denoted by ERFC of x and defined as ERFC of x, that is equal to 2 divided by square root pi integration x to infinite e raised to minus t square dt. So here what is the difference between error function and complementary error function? Here limit is from 0 to x, and here in integration limit is from x to infinite. So this is the difference between error function and complementary error function. Now we will discuss properties of error function and complementary error function. So first property is error function of 0 is equal to 0. Then error function of infinite is equal to 1. Then addition of error function and complementary error function is 1. Then error function of minus x is equal to minus of error function. Now we will discuss unit step function, which is also called Heaviside function. So unit step function is defined as u of t minus a, that is equal to 0 for t less than a, and it is equal to 1 for t greater than equal to a. So here we can see in this graph u of t minus a is equal to 1 whenever t is greater than equal to a, and u of t minus a is equal to 0 for t less than a. So this is the graph of unit step function, which is also called Heaviside function. Now we will discuss pulse unit height and duration function. So the pulse of unit height of duration t is defined by f of t is equal to 1 for 0 less than t less than capital T, and otherwise it is 0. So here one pulse is generated by this function. So here if we have to generate one pulse, then we can generate it by this function. Now we will discuss next function, that is rectangle function. So a function f of x defined on R is said to be rectangle function if f of x is equal to 1 for a less or equal to x less or equal to b, otherwise it is 0. Now we will see the graph of rectangle function. So here in this graph we can say that value of function is 1 for a less or equal to x less or equal to b, and otherwise it is 0. So this is the graph of rectangle function. Now we will discuss next function, that is gate function. So a function f(x) defined on R is said to be gate function if f(x) is equal to 1 for mod x less or equal to a, and it is 0 for mod x greater than a. Now we will see the graph of gate function. So here in this graph we can say that value of function is 1 for mod x less than a, because when mod x is less than a, then x will vary from minus a to a. So from minus a to a, value of function is 1, and for rest values of x, function is 0. Now we will see Signum function. So the Signum function of f is defined by f of x is equal to 1 for x greater than 0, and it is minus 1 for x less than 0. So now we will see the graph of Signum function. So here we can see that value of function is 1 for x greater than 0, and value of function is minus 1 whenever x is less than 0. So this is how Signum function is defined. Now we will see next function, that is sawtooth wave function. So the sawtooth wave function f of x with period a is defined by f of x equal to x for 0 less or equal to x less than a, and the graph of sawtooth wave function is as follows. So here in this graph we can say that f of x is equal to x for 0 less or equal to x less than a. We can see here whenever x lies between 0 to a, then f of x is x, because this is y equal to x line. Okay, so this is the graph of sawtooth wave function. Now we will see next function, that is triangular wave function. So the triangular wave function f of x with period 2a is defined by f of x is equal to x for 0 less or equal to x less than a, and 2a minus x for a less or equal to x less or equal to 2a. Now we will see the graph of triangular wave function. So here this is the graph of triangular wave function. So here in this graph we can say that f of x is equal to x for 0 less or equal to x less than a, and for a less or equal to x less or equal to 2a, it is 2a minus x. Okay, so here for 0 to a, f of x is equal to x, this is f of x equal to x line. Okay, and for a less than x less than 2a, it is 2a minus x. Okay, so this is the graph of triangular wave function. Now we will see half wave rectified sinusoidal function. So the half wave rectified sinusoidal function f with period 2 pi is defined by f of x equal to sin x for 0 less than x less than pi, and it is 0 for pi less than x less than 2 pi. So now we will see the graph of half wave rectified sinusoidal function. So this is the graph of half wave rectified sinusoidal function. So here we can clearly see that f of x is equal to sin x for 0 less than x less than pi. Okay, and for pi less than x less than 2 pi, it is 0. So again for 2 pi less than x less than 3 pi, it is sin x, and for 3 pi less than x less than 4 pi, it is 0. So this is called half wave rectified sinusoidal function. Now we will discuss full rectified sine wave function. So the full rectified sine wave function f of t having period pi is defined by f of t equal to sine t for 0 less than t less than pi, and f of t plus pi is equal to f of t, because here this is a function having period pi. Okay. Now we will see the graph of full rectified sine wave function. So this is the graph of full rectified sine wave function. Okay. So here we can see that f of t is equal to sine t for 0 less than t less than pi. Same way here we are getting the sine function. Now we will see square wave function. So the square wave function f of x of period 2a is defined by f of x equal to 1 for 0 less than x less than a, and it is minus 1 for a less than x less than 2a. Now we will see the graph of square wave function. So this is the graph of square wave function. Here we can see that whenever x is between 0 to a, then value of function is 1. Okay. Whenever x is between a to 2a, then value of function is minus 1. Okay. So this is the graph of square wave function. As here we can see that square wave is generated. So in today's session we have discussed about some special functions. Thank you for watching this lecture.